In the context of a virus that can mutate so often and still retain its transmissibility and virulence, influenza virus and its genome and the ability to accept different genetic material from different strains of an influenza virus is a hot topic. This study is focused on a type of avian influenza strain, which led to a big outbreak and epidemic across Eurasia in 2016 to 2017. They're focusing on the H5N5 strain as well as H5N8. The H and the N are surface proteins and are of interest for viral entry into the host. This is also of interest because it's a hybridized virus that can travel with migratory birds like waterfowl, who can infect domesticated ducks and chickens, leading to the possibility of highly pathogenic avian influenza, or HPAI. Can I confirm at this point, actually, Augustine, is it true that the migratory waterfowl can share this virus with domesticated chickens?
Yes, actually, this is the important point they found in this paper, because in the previous outbreaks or in the previous epidemics, it was mostly the domestic or bird like poultry were shedding the low parts. But in this epidemic, they observed that the wild bird actually involved in the shed, in the providing the material genetics of low parts and the reassorts with the high parts. Yeah, right.
And this is, I didn't remember how many samples they got, but I assume this is hundreds or thousands of samples. And are these samples from the wild birds or from the domestic birds, or both?
For both, actually.
Okay, I got it. So that's why this is so interesting for them, because not only is it damaging for wildlife and livestock, it's got the possibility of a zoonotic infection and possible outbreak or even pandemic in humans. So understanding how it mutates is really key. And that's the meaning of these charts. The charts show, on the one hand, the dendogram shown by these phylogenetic charts of the different clades that are represented in the different segments of the virus genome. Influenza viruses can be divided into 8 segments, each segment coding for different functions. The segments of a special note might be segment 4, which encodes for the H surface protein. And so I'll just start by looking at this phylogenetic tree of segment 4. And what's notable is it's all the same color. This red color represents group A. And so every influenza virus on this one was A virus, defined by the surface protein hemagglutinin. And also, maybe I could ask Bazka. Bazka, is it the case that humans are only affected by A virus?
B too, but most dominant is A.
Right. Sometimes we go to the doctors and we get this confirmation, this diagnosis. Oh, you got influenza. What kind, A or B? It's like that kind of A and B?
Sure.
Okay, and the case that could jump from the animals to the humans might be the A type. So they're all the same color. Now, what's difficult to read in this chart maybe is the relationship between this phylogeny and the heat map. Well, to look in a simple way, we might notice that all of this is a single clade, which is group A in the phylogeny. And if we look at column 4, which represents the same genetic data, the column 4 is 100% red because there's only one possible group of segment 4. So 100% red on there. And in fact, on the heat maps for every segment, segments 1 through 4, as well as segments 5 through 6, column 4 is 100% red because there's only a single group. If we look at segment 1, which has a lot more variation, there's 4 different clades represented by each of these colors on these branches. Now, the easiest case to me to look at seems to be this clade from 2016 on day number 26. This is a group A clade, and so segment 1 on this segment 1 phylogeny is completely red. But you'll notice that segment 2 is also completely red, meaning, okay, now this is the part that I might get wrong. So I'm going to try to say this and please give me feedback. I think this means that for all of this clade, for segment 1 that was in the A group, its segment 2 genome is also completely A. However, parts of its segment 3 genome in the group down at the bottom shows genetic material from group D. 4 is, of course, all group A. 5 is all group A. Now, 6 is a different case because 6 is the N surface protein. And so these left column color key has no bearing on column 6. Column 6 color key is completely related to the N type. And the N type column is only related to column 6. And as I mentioned earlier, we are only investigating 2 N types. N5 represented is the top group, the group in green, and N8 represented in purple. Okay, and then if we continue to compare this bottom clade with segments 7 and 8, they also have very little mixing. It seems to be 100% red. So in other words, this clade from 2016, day 26, has very little genetic information from other strains, except it just has a bit on segment 3 and a little bit on segment 6. Whereas if we look at the top 3 clades, there is a lot more genetic mixing with other strains. Okay, Augustin, Bazka, did I get that mostly correct?
Yes, almost correct. But maybe apart from the N, you said maybe N5 is actually N6 and N8.
Oh, is there N6 on here?
Yes, only N6 and N8.
I thought that this color, this green color is N5.
And maybe you are right.
Yeah, it seems
Yes.
like this color matches with the N5 color.
Yes, right. Sorry.
Okay.
Yes, right. Yes, I think, you are right in your explanation and the interpretation also.
Okay. Would you mind adding a few more things which I missed? Is there what else would you like to highlight to somebody who was looking at this?
I want to highlight the regional level.
Right.
Now we just talk enough about each segment and reassortment, but I really want to highlight that regional level. You know, this is the quite more variable for each segment.
It is, yeah.
Yeah, maybe we should a little bit highlight in case of the HA or NA, not for all of them. Yeah, and maybe for order of your speech, first of all, you should generally talk about the virus. For example, virus contain H segment, which one, for example, HA, NA, most important in terms of the like genotyping. And for the genotyping, such kind of the phylogenetic analysis performed. And for example, in TP2, there is the four grouping or grading based on the genetic analysis, and those can be led to the representative genes, and those genes can also show the combination which we call the reassortant like this. First it should cover the general understanding.
Sure.
Later on you can move to the more detailed grouping, grading, each segment and combination, and later on, lastly, you can talk about the geographical section. Yeah, this may be good.
Okay.
For newcomers.
Right. Would you agree that segments 4 and 6 are the most important to focus on?
Yes, sure. And maybe if we talk each of them, we don't have enough time.
Right.
And among the 8, actually HA and A most important.
Right.
Then other.
Can I get your comment then on this the top clades in segment 4? Because in my first explanation, I focused on the easier cases where this bottom clade from 2016, day 44 on segment 4, has relatively low amounts of reassortment. But the clades 2016-44 and 2016-57, and then also this 2015-54, they have quite a lot of reassortment, it seems like. Would one of you mind trying to tell us the significance of this? Because there's even some mutations on 7 and 8, which were generally more stable than others. Is this especially dangerous when you see a mixing like this? Does that make you more nervous about host jumping or something like that?
Yes, I think actually this is the critical point actually for the influenza. So this reassortment means even the population cannot have immunity against the current or the usual strain that's circulating in that population. So if new genetic material are included in the virus circulating, means the population has no immunity against that new virus. This includes the risk of maybe increasing the pathogenicity. So that is the critical point. I think you should maybe also focus on this diversity of the reassortant strength. This is most important for the influenza. Because if it's the same one, so it means the risk is quite low because the population has already immunity. But if many reassortant means no any more immunity, and the risk of including some genes that can increase the pathogenicity or the virulence, the risk is also high.
Right.
Yeah. Another thing is that the little earlier Augustin said that the reassortment comes from the different combination of the gene, especially HA. Because of that, HA is the surface protein. So, HA also the one of the key for the for the explanation of the pathogenicity. For example, if once the pathogenicity change from the low to high, it's quite related with the HA. So mean that it seems to be like all of them red, but the combination very important. If that in the critical region there is the insertion deletion, I mean the nucleotide change, that can be cause of the pathogen change from low to high, high to low, something.
Right, right.
This is actually one of the point Augustin wants to say. Is a risk. So maybe you can include something like that in your speech.
If I try to find the branch that looks the most dangerous, I'm looking on segment 4, and I would guess that it's somewhere around here. I'm just roughly trying to find a place that has the most diversity of colors. So something like this has 1, 2, 3, 4, 5, around 5 different groups within a single genome. That should I be most concerned about something like this branch?
Yes, I think.
Okay, so then I might try to find the region here, although it's so small it's kind of hard to see exactly where that is. But maybe, I don't know, if I was really interested in finding more, I might think that this region here could be a potential area to search for danger.
So in this case, if you point that region, so that region is actually Africa and South Asia. Yeah.
Oh, and there's not much Africa represented on this whole thing. And so perhaps that's one reason why it did mix so much.
But the red one is Africa.
Right.
The purple or pink one is South and East Asia. Yeah. But according to the conclusion of the study, so the most reassortant occurred in the Eurasian region. And yes, and actually this mutation led to the increased virulence in the worldwide population.
Right. Okay, you guys, I really appreciate that, because me and my students were really wanting to be able to describe these kind of heat maps with a dendogram, and you guys have helped us a lot on that. Do you have any final comments?
It's okay, everything is clear.
Yeah. You study well.
Bazka, you came and gave this to me last Friday, so at first I was scared, but I said, I have to try.
This is a really good summary study. If we go to more detail, it's more difficult, but it's quite nice study. Yeah.
Well, and the students will have a chance to bring in their own graphs related to their own field. So I thought this was a really nice one, because we are all at least a little bit familiar with influenza. So this was nice to learn more about it. Thank you.
Welcome.
Thank you so much.
All right, you two. I really appreciate your time. And if a student chooses to do this one for their homework, maybe I'll share the results with you too.
Okay.
Okay. Thanks, you guys.
All right.
Okay, thank you. Take care.